Today we're going to just do some practice problems converting binary to decimal and decimal format back to binary. So first we're going to start with binary to decimal. So we have 3 examples here on the board, and please pause this video at any time and kind of go along with it. So we're going to start with problem number 1. We're showing a binary code of 110011. And we're going to convert that to decimal format. So remember from my last video, we talked about base 2 and writing out base 2 in order to convert. So what I'm going to do for simplicity is I'm just going to actually write out base 2 above each number as we go. And if you get confused, please look at my other video and just kind of follow along. So we're going to start with a 1 here. Here we're going to put a 2, then a 4, then an 8, then a 16, and then a 32. And we're going to stop there because we're done with the binary itself. Now we're going to add up each individual 1. So we're going to start here at the 32. So we're going to do 32 plus 16. We're going to skip 8. We're going to skip 4 because those both have a 0. And then we're going to continue along with 2 plus 1. And if we calculate that out, we come out with 51. So the binary format, the decimal format of 110011 is 51. Okay? So next we're going to go to problem number 2. And like I said, pause the video at any time. That way we can all go over it together and see kind of how far you're going. So now we're going to start with problem number 2. Again, we're going to do 1, 2, 4, 8, 16, and 32. And we're going to stop there because we have no more numbers. So again, we're going to add up each one, not zeros, just the ones. So we're going to go 32 plus skip 16, skip 8, plus 4, plus 2, plus 1. And that equals 39. Now we're going to start with problem number 3. Again, we're going to write out 1, 2, 4, 8, 16, and 32. If we had a longer binary number, we would obviously continue along 64, 128, 265, so on and so forth. However, we don't need to because we only have 1, 2, 3, 4, 5, 6 places for binary. So again, 32 plus 16. We're going to skip 8. We're going to add 4 to it. And that's it. We have no 2s and no 1s. So we're going to add those together. And that equals 52. 52. So that is converting binary to decimal. We take the binary number, we write the base 2 above it, the 1, 2, 4, 8, 16, 32 for each placeholder, and then we add the 1s and we leave the 0s in their place. So now we're going to scroll down and we're going to do the opposite. We're going to convert decimal to binary. Decimal to binary. Now I have 2 examples up here. We have the number 86 and we also have the number 117. 117. So what I'm going to do with this one is I'm actually going to write out the base 2 all the way to 128 up above. And we're going to use that for both problems. So we're going to start with 1, then go to 2, then 4, 8, 16, 32, 64, and finally 128. Now we're going to start with problem number 1, 86. So we have to find out up here where the base 2s are, the 1, 2, 4, 8, 16, 32, 64, 128, what number fits into 86? Well, does 128 fit into 86? Well, no, it does not. So we're not going to do anything with 128. What about 64? Does 64 fit into 86? Well, yes, it does. So we're going to subtract 64 from 86. So we're going to do 86 minus 64. And that gives us 22. 22. So now we're going to put a 1 in where 64 is, because 64 does fit into 86. So now we're going to continue down the line. Does 32 fit into 22? Well, 32 does not fit into 22, so we're going to put a 0. What about 16? Does 16 fit into 22? Yes, it does. So we're going to put a 1. And we're going to subtract 16 from 22. So now 22 minus 16, and that equals 6. So now, does 8 fit into 6? No, it does not. So we're going to put a 0. What about 4? Does 4 fit into 6? Yes, it does. So we're going to do 6 minus 4. That equals 2. So we're going to put a 1 where the 4 is, because that did fit. What about 2? Does 2 fit into 2? Yes, it does. So we're going to put a 1. And then finally, 2 minus 2 equals 0. And now we stop. So because 1 doesn't fit into 0, we're going to put a 0 there to finish it off. So the binary equivalent of 86 is 1010110. So now we're going to erase up top right here, because we're going to use the exact same base 2 for 117. For 117. So again, we're going to start with 128. 128 does not fit into 117, so we're going to not start with 128. What about 64? Does 64 fit into 117? Well, it does, so we're going to put a 1 there. 117 minus 64 equals 53. Now what about 32? Does 32 fit into 53? Yes, it does. So we're going to put a 1. 53 minus 32 equals 21. Does 16 fit into 21? Yes, it does. So we're going to put a 1. 21 minus 16 equals 5. Does 8 fit into 5? No, it doesn't. So we're going to put a 0. Does 4 fit into 5? Yes, it does. 5 minus 4 equals 1. We're going to put a 1 there because 4 fit. Does 2 fit into 1? No, it does not. Does 1 fit into 1? Yes, it does. And that finally equals 0. So 117 equivalent is 1110101.